now I'm going to give you guys some practice. So I'm going to ask you a question, and then you would have to pause it and have a go, and then unpause it to see the answer. So here, let's say you're given this graph here. Your eyes should zoom into this. So it's a speed time graph. Okay. At the moment, for the time being, it's always speed time for the time being. Later on, I will change this to other things. Okay. But for the time being, it's speed. So this is a speed time graph. Imagine it as like this. You and your dad are sitting in a car. So you and your dad are sitting at time equals 0 here. So looking at this graph here, there's going to be, well, your dad is going to put his foot on the accelerator. So he's going to accelerate because, well, there's going to be an acceleration between 0 and 3 here because there's a slope. Now the question is, what is the acceleration between 0 and 3 seconds? So what's the acceleration between, well, if you are here and your dad puts his foot on the accelerator, there will be an acceleration. That means there's an increase in speed. What is the acceleration? And express it with the units as well. So you've got to remember what the unit of acceleration is. Okay. So press pause and have a go. Okay, so the acceleration between 0 and 3, well, the acceleration is the gradient of this line here. Because okay, let's look at this. The acceleration is well, work out the gradient. The height here is 3, and the across here is also 3. So the acceleration is 3 divided by 3, which is 1. Okay, and if you ever forget what the unit is, then the unit of the up and down here is speed, which is meters per second, and then you have to get the up and down here, which is meters per second, divided by the cross here, which is speed. So you divide it by speed. So this thing gets multiplied to the bottom. So it's really meters per, well, it gets multiplied to the bottom, so it should be like this, squared. But then we would write it as 1 meters per second to the power of -2. Okay, or you can write it like this, but most people prefer this. Well, it's up to you. So the acceleration, so between 0 and 3 seconds, there's an acceleration of 1 meters per second. Per second squared, sorry. So what that means is every second the speed will have increased by 1, and it does make sense. Look at this. The speed here is 0. After 1 second, the car's speed is 1, and then after another second, it would have increased by it would increase is 2, and then after another second, well, the acceleration here is 1 meters per second squared, and you might be asked, what is the acceleration at 1 second, or what is the acceleration at 2 seconds? Well, the acceleration at 1 second is exactly the same as the acceleration at 2 seconds, because well, the gradient would be the same, so the acceleration would be the same. Okay. Now next question. What is the acceleration at time equals 5? So I want to know the acceleration at time equals 5. So what is A? A is what? Meters per second squared. So fill in this gap. So press pause and have a go. Okay, so the gradient at the acceleration at time equals 5 here is well, the gradient is, well, the up and down here is 0, and then you divide it by, well it's going to be 0 divided by something. So well, the gradient here is actually 0. Okay, so the acceleration is 0 meters per second squared, which means your dad sitting in this car is traveling at a constant speed. There's no acceleration. There's no acceleration, meaning there's no change in the up and down of this line. This line here, between here and here, it doesn't go up or down. It stays the same. So when there's an acceleration of 0, it means that the speed, well, the speed is not changing. So when the acceleration is 0, it means there's no increase or decrease in speed. So it's always constant. Anyway, next question. What is the acceleration at at time equals 8. So at t equals 8, what is the acceleration? Acceleration is what per meters per meter squared. Well, per meters per second squared. Okay, so well, what goes in this box? Press pause and have a go. Okay, so the gradient at time equals t, so that's here. What is the gradient here? Well, the gradient here is the same as the gradient here, is the same as, well, just work out the slope here, basically. So here, the height here is 4, and then the across here is 2. So 4 divided by 2 is 2. So between 7 and 9 seconds, the acceleration is 2 meters per second squared, or sometimes people would pronounce it as per second. Sorry, 2 meters per second per second. Sometimes it's said like that, but it's up to you how you say it. So here, what that means is every second the speed would have increased by 2, because look at this, 1 second and then it increased by 2. 1 second increased by 2. That's what it means. Okay, so here the acceleration here is 0, so that means your dad is going at constant speed. Here the acceleration is 0, constant speed. Now my last question is, what is the acceleration at this point here? Okay, so at 11.5 seconds, or between 11 and 12 seconds. So what is the acceleration here? Okay, so press pause and have a go. Okay, the acceleration here would be, well, just get the height, which is 3, divided by the across here, which is 1. So the acceleration here is 3 meters per second squared. So what that means is every 1 second there will be an increase in speed by 3. So look at this, 1 second, an increase of 3. Okay. Okay. Next question. Hang on. Let me get rid of this one here. Okay, so given this here, what is the acceleration at time equals 3? So at time equals 3, what is the acceleration? So time equals 3 here. What is the acceleration here? Press pause and have a go. Okay, it's a trick question, but the acceleration here is 0. Okay, what is the acceleration here now? Okay, so my next question is, what is the acceleration at, let's say at t equals 6? What is the acceleration? So press pause and have a go. Okay, so the acceleration here is, well, let's just get the height here, which is 6, and then divided by the 2 here, the across here, which is 2. Well, the acceleration will be 3. So when there's an acceleration of 3, what that means is every second there would be an increase of 3. Well, there's an increase in speed of 3. Okay, so after 1 second, there's an increase of 3. You see, an increase in speed of 3. Okay, so next, okay, last question here. Well, okay, what is the acceleration at this point here? At 5.2. Okay, what is the acceleration when t equals 5.2? So it would fill in this box here, meters per second squared. So press pause and have a go. Okay, so at 5.2, somewhere in between here. Okay, so at this point here, the gradient at this point here will be the same as here, will be the same as here, will be the same as here. So I'm just going to get the whole height here, which is 2, divided by the across here, which is 7. So the acceleration here will be 2 over 7. I'm just going to leave it as a fraction, because a fraction itself is a number, so you are allowed to leave it as a fraction. So just say the acceleration is 2 over 7 meters per second squared. Okay.